certainly don't get any, right? Can you just anyone give an example? So suppose this is an AP. 2D1 and so on. And then there is this one. So if we merge them, will it be an AP? Okay, these are like, once you know it, you see it very, very simple. These are almost just like conceptual questions. These are not even problems.
Oh, no, it does not form any.
Just give an example.
Say 1, 2, 3, 4, 5, 6, 7, 8 all the way to 100 or something, and then 2, 4, 6, 8, 10, 12, 14. You can add them and see.
2, 4, 6, 8. Right. And then if you just merge them like the way we define merging, it obviously doesn't. It just makes no sense. Doesn't form anything. In that case, it was forming. That is. So, getting allergy. Right. Okay. So it won't be. There's not much interesting. Let's move to the number theoretic side a little bit. Right. So, like the first question we said is that if you have an arithmetic progression, right, 2D1 and so on, and if you have another one, and we said that if there is one term in common, then there are infinitely many terms. That's a very easy question, but let's just try to see it from a number theoretic perspective. Then the harder ones also we can see from that perspective, and then it will be useful. That perspective will be useful in that case. And so on. So what does it mean to say that there is a term in common? So we are saying that this d1 is equal to some x, and that x, same x, just using that x. It doesn't, you don't have to use that x, it's just then n minus 1 times some d2. Let us say all these are integers for the time being. Okay, I mean, they were integers anyways. Yeah, by the way, so all the things we did, it sort of, we assume that they are with integers. Okay, whether they are true, if these things are not integers, that is another good question. Okay, which I will come to. But keeping everything as integers, let us see. Okay, then we can ask for the rational case, and then you can ask for the irrational case. Okay, what happens if? Yeah, it will be interesting question. This, right? So this is what it means to say that there is some term in common. Okay, so you can in your mind you can keep it like if it's needed, that you say that it is something like this. This thing is equal to, could be anything, that doesn't matter. Okay. So what does it mean? So if you think about it number theoretically, what it means is that there is a number x These two are the same numbers. Let's call it x, okay? Because we want to refer to both of them, the properties of x with respect to these equations. What it means is that this d1 divides x minus a. Is that right? That's what the first equation, right? And the d2 divides x minus b. Okay. So now you have to interrupt me and tell me if there is something which is not there. Okay. I'll assume that because if I do say ask this a lot of times. I think it's not needed. But please tell me if anything. You just interrupt me and tell. So what this means is that the d1 divides x minus a1 and the d2 divides x minus. Same x works. I mean, you can also just look at this equation in a slightly just a division remainder form. X is a number which, when you divide it by 20, divided by d1, the quotient came out to be 20 and the remainder came out to be a1. It's not a very precise statement, but it looks like that, right? Because I mean, it will say, yeah, a1 has to be less than 20, otherwise it doesn't make sense. But yeah, you understand the point. This is what it means. Now, yeah, if you know model arithmetic language, then what this means, and if you don't know, then there's not a problem. This is just this is written like this. Okay? And the second one is written like this. It's just the way to write. It has many advantages. This is what these things mean, but it's not necessary to know this. So we have translated this problem about two arithmetic progressions intersecting into this same problem about divisibility. d1 divides x minus a1 and d2 divides x minus b1. And it's the same question as the two arithmetic progressions are intersecting. The same thing. Okay. So basically, we have taken out the thing that was not important, and it was which term it is intersecting. And this is more, so that's why it's a more crisp language. It has taken out the unimportant thing from the picture. Okay. So what should we do with this? Well, let us use this newfound translation maybe to maybe say, I mean, when will two arithmetic progressions have something, will have definitely something in common? Let's ask that interesting question, right? Let us ask that. So let's see, I mean, so from here, okay, if this is a question that can be asked about arithmetic progressions, and then you can translate it in this and try to answer. But if, let's say I tell you that if d1 is 5 and d2 is 12, right? So d1 is 5 and d2 is 12. Okay. Now, Satya, you give me some a1, any a1 you want. Big, small, anything.
All right, so like, okay, 3.
3. Okay. Nandini, give me a a2. Sorry, b1. Any b1.
So 6.
Okay. Yeah. So anything. 6. Fine. Okay. Now my claim is that the arithmetic progressions you make will have something in common. You make you now just write the arithmetic progression and check. This is not a question to check. There are two arithmetic progressions that will come. Write them and see for yourself that there will be something in common. And if you can find that thing, then you tell me.
Yeah, you can just write the equation 3 plus 5d is equal to 6 plus 12d, right?
Better. So you don't even have to write the arithmetic. Okay, yes, that's a more mature way to do it. But my point is that, yeah, we should do it like that only. But even if you don't do like that, if you just write the AP also, you will see at some point that they match. So let's first do maybe that for us. 8, 11, then 5 is 13, 18. Okay, maybe it will, I don't know when it will reach. So 23 and so on. And this one starts with 6. Yeah, starts with 6 and then 18, boom. So you see 18 is there. Now, I did not choose the A1 and B1 and it came out to be matching. Okay. But you see, this is fine. But as Satya is saying, it's better to just write the equation and do it, right? So now you can just write the equation. So you have 3 times, okay, 3 times some m. This is the general term, right? This is the general term of the first arithmetic progression and the general term of the second arithmetic progression. And we will ask if there is some m and n which satisfies this thing. Okay. It's not a trivial thing to just solve it, right? Because there are 2 variables, 1 equation. And you want to solve it in integers, not anything. But first you should notice that this m minus 1, n minus 1 is really bad. There's no need to write like that, right? You can just write m and n. There's absolutely no need to write that like that. You just write m and n, but maybe there might be a mix-up, might be. So I'm for the time being just writing k1 and k2. You just want to solve this. You just want to find k1 and k2, which will work. And this is what 12k2 minus 5k1. So just check it is minus. You just want to solve this. You can just guess a solution. So guess some k2 and k1. It is already there. We already found it. It's that term. Right? Just make a guess. Let's try.
For it.
4, 8. Yeah, nothing before
No.
that. 1 and 3, maybe.
4 and 2. The next one is it?
Next one. Anyways, 1 and 3 work, right? K2 equal to 1 and K equal to 3. And yeah, right. You are right. It's 4 and 2 to be precise. Yeah, but right. So it's fine, right? So K1 is coming out to be 3, which means it's the 4th term, right? Because I mean, this is the 4th term. If this is 3, and this is the 4th term. So, anyways, you understand, right? So that's it. Now, as you understand, this A1, this 3 and 6 are not important because this is not, I did not pick that, right? So you pick anything, any A1 and B1. What do you get? It translates into this. Please tell me if this is not working out. Yeah, I will try to explain. Can you solve this for any B1 and A1? Okay. This will pick up next time. This might be confusing a little bit. So what the question is saying is that for any B1 and A1, any numbers B1 and A1, you should be able to find. Means that if you take B1 to be 5 and A1 to be 2, B1 to be 3, A1 to be 2, anything, you write 1 there, still you should be able to solve it. Okay. And we will show that you can solve. And we have also done this in the number theory class. Nagesh, you will recognize this maybe, right? That you have already completely answered when this can be solved, when this cannot be solved, right? Because 12 and 5 are co-prime, so you can always solve this equation. Okay. But for others, we will just come to it in maybe in a different way. We will see. So this problem of arithmetic progressions is just this problem of number theory. But yeah, one has to do it in that context because right now you cannot mix up everything all the time, right? You might get confused. But this is the thing. And maybe when we say more, then I will say the why in the important case the answer to the original question was yes. That if first two APs intersect, second and third intersect, then in fact all three intersect. Okay, and I will say in when it is true. But then let me ask one more question, and this you can again this will be a little trick if you may find it a little difficult to approach, but that's a try. Yeah, because the standard problems is there in the books. Yeah, I've suggested you try, but these are just a little. So if A1, A2, A3 are three APs, again write out if you want, write the APs, write the numbers also examples. That's all that you have to do. Okay. If A1, A2, and A3 are three APs, okay, such that any two have something in common. Then do all three have something in this almost look like I'm just changing a few words here and there, which is what I'm doing. But try these are yeah. Think about this. I don't know the answer myself, so but I will do it with you guys. But I can see that this can be okay. Just give me a minute. There is a like, first two have something in common, and second and third also have some terms in common. First and third also have some terms in common. Does it mean that all three must have some terms in common? Doesn't look true, right? Yeah, does not look true to me. Does not look true to me. We will check it. Huh? Yeah, it is. Let me give a few more, maybe one or two more questions. So we have completely. Yeah, question. This will go back to recurrences. So we have done this, right? That if you have a recurrence, maybe if this term is A and this term is B, to take some numbers there, right? This term is C. Okay. If you can write something here, so maybe yeah, I'll keep the capital A to be 1 only. It's not important. So you can just take something here so that it is you need to minus 5 an minus 1 plus 6 an minus 2. So we have done this question, right? We have said that the answer to this is like you find the roots of this, right? You find the roots of this quadratic. Let's say that the roots are alpha 1 and alpha 2. Then the solution looks almost like this, but there will be some things here which will be unknown. right? Some x and y, which you have to figure out by using the first two terms. First two terms have to be given. Otherwise, the answer would be like this: x and y are not known. Otherwise, the sequence is not known. You cannot do anything about it. Have we done this? Is it? Do you guys agree? So you can execute it for any quadratic, right? So if you have this, you will say, okay, no, look, this is just because it has 2 and 3 as roots, so I will just write this. It's advisable to just think how we did it also. Maybe not now, but it is. Okay, how just wait. How did we do it? Let's try to go back. Okay. So, and do it. But for the time being, you can do this, right? Then you say, okay, it's x and y, some x and y which I don't know. X times that and y times this. And then you say, okay, a1 is a given, a2 is given, x and y you can solve and find it solved. We have done this, right? And now, let me ask slightly tweak it a little bit and see if you can do it. Solve an minus 2an minus 1 plus an minus 2. And a1 equal to a2 equal to, try this. Okay. And then try this. And also try this. So an minus an minus 1 minus an minus 2 plus 3 equals to 0. Okay. Now there is extra 3. How do you deal with it? Try. Okay. Think about this. So again, you can just take first two terms. It doesn't matter to me. So I'm not trying to say that it doesn't always matter. That will depend on the context. But for now, I'm just saying that not very important. Yeah, maybe here I can just say find 100 for the second question. I mean, for this one also, you will not have a direct formula, will not work. You have to see some terms and see some pattern. Now, I'm not giving a question which will be straight from the formula. Neither it will be there like in your exam, mostly. Yeah. So these are the questions. And now maybe you can give one more interesting question, which is 2 recurrences combined. We can pick those up next time. So there is one recurrence which is dependent on another. So usually we use this, but there are 2 sequences, okay? 2 sequences. And it is like this. Okay, not 3, 2 only. Minus 1 and also maybe minus 1 equal to bn minus 2. A mixed. Okay. And now you have to solve them. And again, it doesn't matter. So you can take a1 to be 1, b1 to be 2. Maybe you will also need a2 and b2. So we just take something. Okay. So right. So it's not completely systematic, but it is. Now, one more question. Now we have enough questions to be discussed for next 2 classes, and learn more things through this. But these are easy. Let's try one more. So let us say that there is this road, and this is now you have to count something, and hopefully we'll apply recurrences to count them. 4, 5, 6, 7, 8, and it goes on. Let's say till 20. But you can first do for 5, 6, 7, or it's up to you. You can do the simpler questions. So there is this journey. A journey counts as taking steps from 1 and reaching to 20. And the rule is that in each move, you either take a step of length 1, or you can also take a step of length 2. It's up to you. Or again, you can take a step of length 1, or you can take a step of length 2. Let's keep it till 8 for the time. This is one particular journey. You went all the way from 1 to 8 by some sequence of 1s and 2. You took first 1, then 2, then 1, then 1, and then 2. You reached 8. Very good. This is one journey. And there could be another journey. This is one journey, right? There could be another journey where you take steps of 2s only. Okay, maybe. Oh, did I miss something? No, that's the nature of it. This is another journey. So the combination of the 1s and 2s is different. Yeah, the ways in which it appears and adds up to 8, that's all that is happening, is different. And my question is, in this way, how many journeys are possible? I've described what a journey is, right? How many journeys are possible? You can just do for 1 to 4 and try. Okay? So how many journeys are possible? Do as much as you can. If you can do it for till 5 or 10, you can do it in general, very good. But let's see. How many journeys? So this is journeys. Yeah, you just right. Yes, if that is how it is. Is it like is journeys like this, or is it like this? Wait, which one is correct? It should be the latter, right? Wait. Okay, never mind. I think it's not interesting.
He is the second one.
It's the second one of, yeah, this is obviously
Wise.
wrong. Oh, this one only. Oh,
Yeah, right.
Okay. Yeah, I think so. I cannot.
Even I'm not sure. Even I'm not sure.
Yeah. Leave it. So how many journeys are possible? So this is the question. This is the interesting question. And yeah, you again see that the answer to this question is going to be the answer to a few classes back. We did some rectangles and ratio and that solution, and this answer is also related. It comes down to similar thing. Maybe we'll stop. Is there some other interesting question? I mean, there are many, but it has to be fit in a certain way according to some plan. Yes. So let's leave it like this. Okay. Now you have plenty to try. Okay. We will meet next week and try. Means that you try first and then. Okay. And so we have done this arithmetic progression. So yeah, the little bit. Yes, I have nothing to say. If you ought to feel that there are some topics which you want to do, then just visit the school books or something and just go and solve. Like APs or simultaneous equations or quadratic equations. There's interesting problems in that. Even at the school level, you'll find interesting problems. Don't underestimate them. Okay? Do them miscellaneous section. So quadratic equations is one topic which you should, if you do now, you will get the lot of out of it. Arithmetic progressions, quadratic equations are certainly two topics which will help here, and it will be back and forth useful. So go and look at it, okay, if you have the time. But certainly try this. Okay, so that's it for today. See you next week.
Thank you.